January 5, 1945. Yokosuka Naval Air Base, Japan. Vice Admiral Takijirō Ōnishi stood in the cold morning air, watching ground crew carefully unload a damaged American fighter from a transport aircraft. The Grumman F6F Hellcat, still bearing traces of its original U.S. Navy markings beneath hastily applied Japanese Hinomarus, had arrived from Formosa the previous evening. Bureau number 71,441. Side number 29 from Fighting Squadron 44. The aircraft represented more than salvaged wreckage. It embodied the weapon system that had systematically destroyed Japanese naval aviation over the past 18 months. Every senior officer at Yokosuka understood what this examination might reveal, yet none wanted to confront the mathematical certainty those revelations would bring. Onishi, architect of the Kamikaze strategy and one of Japan's most experienced carrier aviation commanders, had requested this evaluation personally. He needed to understand why Japan's finest pilots were dying at unprecedented rates, why formations of 20 or 30 experienced aviators would engage American carrier groups and return with 5 or 6 aircraft, why combat reports consistently described American fighters with impossible performance advantages. The answers lay in the battered Hellcat being wheeled into Hangar Three. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The captured Hellcat's journey to Yokosuka had begun the previous day, 750 miles south at Kobe Airfield on Formosa. Lieutenant Junior Grade Charles August had been leading the 2nd Division of Hellcats on January 4th, escorting 6 TBM Avenger torpedo bombers for a strike against Japanese installations. His mission called for strafing parked aircraft after the Avengers completed their bomb runs. Over the target, August's Pratt & Whitney R2800 engine had failed catastrophically. Smoke poured from the cowling, oil pressure dropped to 0. The massive 18-cylinder radial engine, normally producing 2,000 horsepower, seized completely. August had seconds to make decisions that would determine whether he lived or died. He was too low to bail out safely. The coastline offered no suitable emergency landing sites. His only option was putting the Hellcat down on Japanese-held territory and hoping to evade capture long enough for rescue. The hope proved futile. August executed a textbook forced landing in a rice paddy near Kobe Airfield, keeping the aircraft largely intact despite the belly landing. Japanese soldiers reached the crash site within minutes. August, still strapped in his cockpit, found himself surrounded by troops with rifles pointed at his head. He raised his hands slowly, becoming a prisoner of war for the 2nd time in his military career. The first capture had occurred in November 1942 during Operation Torch, when then-Lieutenant Junior Grade August flew F-4F Wildcats from USS Ranger against Vichy French forces in North Africa. Engine problems had forced him to bail out over Vichy-controlled territory. The French had held him briefly before repatriating him after the ceasefire. This capture would prove far more serious. Japanese forces quickly secured the downed Hellcat. The aircraft, despite its damaged engine and belly landing, remained structurally sound, wings intact, fuselage undamaged, gun bays loaded with ammunition, drop tank shackles still attached to the wings. Every system except the ruined engine appeared functional. Local Japanese commanders recognized immediately what they possessed. American carrier fighters had been systematically destroying Japanese air power for over a year. Any opportunity to examine one intact represented invaluable intelligence. Orders went to Tokyo. Transport the aircraft to Yokosuka immediately. Assign top priority. The Naval Air Technical Arsenal must examine this machine before American bombing destroys the opportunity. Ground crews at Kobe worked through the night of January 4th, preparing the Hellcat for transport. They removed the damaged engine to reduce weight. They secured the control surfaces. They drained remaining fuel. By dawn on January 5th, the aircraft was loaded aboard a transport, destination Yokosuka. The 600-mile journey to Japan's primary naval aviation research facility took most of the day. When the transport landed at Yokosuka that evening, Vice Admiral Ōnishi was waiting personally. Behind him stood Captain Minoru Genda, one of Japan's most brilliant tactical minds and the principal planner of the Pearl Harbor attack. Commander Mitsuo Fuchida, who had led the Pearl Harbor strike, stood beside Genda. Lieutenant Commander Shigeru Itaya, commander of the Pearl Harbor fighter escort, completed the group of senior aviators. These were not random observers. These were the architects of Japan's carrier aviation doctrine, the men who had designed the tactics that dominated the Pacific in 1941 and early 1942, the officers who had trained Japan's elite carrier pilots to execute the most sophisticated naval air operations ever attempted, and every one of them understood that Japanese carrier aviation was dying, not dying slowly through attrition, but being systematically destroyed by American fighters they could not match. The Hellcat represented the weapon killing Japan's best pilots. Understanding it might provide answers, or it might simply confirm what they already suspected, that America had achieved technological superiority Japan could not overcome. The examination began at dawn on January 6th. Japan's finest aeronautical engineers assembled in Hangar Three. Lieutenant Kiyoshi Inoue, a test pilot with extensive combat experience, would eventually fly the Hellcat if repairs could be completed. Engineering teams from Mitsubishi, Nakajima, and Kawanishi arrived to examine construction methods and design philosophy. Specialists in engines, armament, avionics, and structures formed into teams, each assigned specific systems to document. Vice Admiral Ōnishi addressed the assembled personnel before work began. His words were recorded in notes kept by several attendees, later discovered by American occupation forces. Gentlemen, we face an enemy whose industrial capacity exceeds our own by factors we cannot match. Their training systems produce pilots faster than we can kill them. Their factories build aircraft in quantities that make numerical superiority impossible for us to achieve. These realities we cannot change. What we can change is our understanding of their capabilities. This aircraft represents the weapons system, destroying our naval aviation. We will examine every aspect of its design. We will test every system. We will document every technical detail. And we will determine whether Japanese industry and Japanese pilots can develop effective countermeasures. The future of naval aviation depends on the work you perform here. The engineers began with the airframe, measuring, photographing, documenting every structural detail. What they discovered immediately challenged Japanese assumptions about American aircraft construction. The Hellcat's wing structure showed sophisticated engineering that combined strength with weight efficiency. The center section, where wing roots attached to the fuselage, consisted of massive forged aluminum spars machined from solid billets. Japanese engineers had never seen wing spars of such size manufactured as single-piece forgings. Japanese practice involved building up structural members from multiple components, assembled and riveted together. The American approach required enormous hydraulic presses capable of forging aluminum sections weighing hundreds of pounds. It required precision machining equipment capable of holding tolerances across components measuring 6 feet long. It required heat treatment facilities that could process such large pieces uniformly. Japanese industry possessed none of this at scale. The wing ribs, stamped from sheet aluminum in dies, showed identical forming across the entire wing. Every rib matched its counterpart on the opposite wing precisely. In Japanese aircraft, ribs were typically hand-formed over wooden templates, then fitted individually to each specific airframe. No two aircraft were truly identical. The American standardization meant any wing rib from any Hellcat would fit any other Hellcat of the same model without adjustment. This level of interchangeability required manufacturing precision Japanese factories had not achieved. But more fundamentally, it revealed a production philosophy oriented toward mass manufacturing rather than craftsman construction. The Americans had designed the Hellcat not merely as an excellent fighter, but as an excellent fighter that could be mass-produced by semi-skilled workers using automated equipment. The control surfaces told similar stories. Ailerons, elevators, and rudders were stamped from dies, their internal structure consisting of stamped ribs and formed sheet metal skins. The Japanese engineers could see that thousands of identical control surfaces could be produced rapidly from the same dies. Replacement in the field would require no custom fitting. Any aileron manufactured to specification would bolt directly onto any Hellcat wing. Japanese control surfaces required skilled metal workers who could hand-form skins, fit internal structures, and adjust assemblies to match specific aircraft. Production was necessarily slower. Field maintenance required skilled technicians. The American approach eliminated craft dependency by building precision into the manufacturing process itself. The fuselage construction proved equally revealing. The F6F used semi-monocoque construction, where the aluminum skin carried significant structural loads, supported by internal formers and longerons. The skin sections were rolled and formed using sophisticated dies. Rivet patterns followed identical spacing across the entire fuselage. Inspection ports and access panels showed standardized dimensions that would accept standardized covers. Most striking was the overall build quality combined with apparent production simplicity. The Hellcat was built to looser tolerances than Japanese fighters. Surface finish was rougher, panel gaps were larger, yet the overall construction was massively robust. Where Japanese fighters were delicate precision instruments requiring careful handling, the Hellcat was a rugged machine designed to absorb damage and continue functioning. American design philosophy had clearly prioritized durability and maintainability over refined craftsmanship. The approach made sense for carrier operations where aircraft would be handled roughly, exposed to salt spray, subjected to violent arrested landings, and maintained by crews working in cramped hangar decks with limited tools. Lieutenant Commander Yasuna Kozono, an experienced maintenance officer who had served aboard carriers Akagi and Shokaku, examined the landing gear with particular interest. The Hellcat's main gear units were massive compared to Japanese fighters. The struts, forged and machined from high-strength steel, could absorb tremendous landing loads. The retraction mechanism, hydraulically powered, showed robust engineering with redundant systems. Kozono had seen too many Japanese fighters damaged in carrier landings, their landing gear collapsing under loads for which they had not been adequately engineered. The Hellcat's gear was clearly designed for the violent carrier landings that were routine in naval aviation. Its wide track, spreading the main gear units far apart, provided excellent stability during landing and takeoff. Japanese fighters, with their narrow gear tracks, required careful pilot technique to avoid ground loops. The Americans have engineered this aircraft specifically for carrier operations by average pilots, Kozono noted in his examination report. Japanese fighters demand skill and careful technique. This fighter forgives pilot errors through robust engineering. In carrier operations where pilot fatigue and poor visibility are constant challenges, such forgiveness translates directly to operational effectiveness. The cockpit examination revealed another philosophical difference. The Hellcat's cockpit was larger and more comfortable than Japanese fighters. The seat was well padded, controls were logically arranged, instruments were large and easy to read. Visibility through the bubble canopy was excellent in all directions. Japanese fighter cockpits were cramped and austere, minimal padding, smaller instruments, more restricted visibility. Japanese design philosophy had prioritized saving weight and reducing size. American designers had prioritized pilot comfort, recognizing that combat missions lasting 4 or 5 hours required pilots to remain alert and effective despite fatigue. The instrument panel particularly impressed Japanese engineers. Every instrument was standardized. Any airspeed indicator from any Hellcat would fit any other Hellcat's panel. Replacement in the field required simply unplugging the old instrument and plugging in the new one. Electrical connections used standardized plugs. Control cable connections used standardized fittings. Japanese aircraft instruments were often unique to specific aircraft types. Replacement required skilled technicians who understood the specific installation. Field maintenance was correspondingly difficult. The American standardization philosophy extended even to seemingly minor components. When engineers examined the oxygen system, they found regulators that appeared to be manufactured by automobile parts suppliers rather than specialized aircraft equipment manufacturers. The regulators functioned perfectly well, suggesting American industry possessed such depth that companies with no aircraft experience could produce precision components simply by applying existing manufacturing capabilities to new applications. The fuel system showed sophisticated engineering oriented toward long-range operations. Internal tanks in the wings and fuselage held 184 gallons. An additional 85-gallon tank behind the pilot, though it created center of gravity issues when full, extended range significantly. Most impressive were the provisions for external drop tanks. Wing shackles could each accommodate a 150-gallon drop tank. With both tanks installed, the Hellcat could carry an additional 300 gallons externally. Total fuel capacity approached 570 gallons, giving the fighter a combat radius exceeding 850 miles under optimal conditions. This range exceeded that of any Japanese fighter by significant margins. Japanese fighters had been designed for shorter-range interception missions. The legendary Mitsubishi Zero achieved its remarkable range through extreme weight reduction and efficient cruise flight, not through large fuel capacity. Japanese drop tanks were crude by comparison, manufactured from thin aluminum that often leaked. They created excessive drag. They were in chronic short supply. The Hellcat's drop tank capability revealed American strategic thinking. They had designed a fighter that could escort bombers hundreds of miles from their carriers, fight over the target, and return with fuel reserves for emergencies. This extended reach meant American carrier task forces could strike targets far beyond the range Japanese forces could effectively defend. After 3 days examining the airframe, engineers turned their attention to the armament system. The Hellcat mounted 6 Browning M2 50-caliber machine guns, 3 in each wing panel. Each gun had approximately 380 rounds, giving total ammunition capacity of approximately 1,880 rounds. The guns themselves surprised Japanese engineers with their apparent crudeness. Built to relatively loose tolerances compared to Japanese aircraft guns, the Brownings appeared rough in construction. Yet test firing demonstrated their reliability. They functioned flawlessly despite what Japanese engineers considered imperfect manufacturing. The design philosophy became clear. American engineers had created weapons that prioritized reliability and ease of maintenance over precision craftsmanship. Any armorer could service the guns using basic tools. Replacements required no special fitting. The guns would continue functioning even when dirty, damaged, or poorly maintained. Japanese aircraft guns were precision instruments. They required skilled maintenance. They were more accurate when perfectly maintained, but they were also more sensitive to combat damage, less tolerant of imperfect maintenance, and required specialized tools for servicing. The Hellcat's gun installation showed careful attention to harmonization and bore sighting. The 6 guns converged at a specific range, creating a concentrated fire pattern. Gun camera footage captured during the aircraft's brief operational service showed this convergence pattern clearly. American gunnery training apparently emphasized firing at optimal convergence range rather than long-distance shooting. The ammunition feed systems used electric motors and solenoids for charging and clearing. Japanese fighters typically used pneumatic or manual systems. The electric systems were heavier but more reliable and required less pilot manipulation during combat. After 8 days of detailed examination, the engineering teams had documented every accessible system except the engine. The Pratt & Whitney R2800 Double Wasp that had powered Buno 71441 was destroyed beyond analysis. The catastrophic failure that forced Lieutenant August to crash land had scattered internal components throughout the engine case. However, Japanese intelligence had previously obtained intact R2800 engines from other captured aircraft. Detailed examination reports existed. The engineers knew the Double Wasp represented American engineering at its finest. 18 cylinders arranged in 2 rows. 2,000 horsepower at war emergency power settings. Supercharger for altitude performance. Reliable operation, despite brutal service conditions. Most significantly, the R2800 was produced in enormous quantities. The same engine powered the F6F Hellcat, the F4U Corsair, and the P-47 Thunderbolt. American industry had standardized on this one engine for 3 major fighter programs, allowing mass production at scales Japanese engine manufacturers could never approach. On January 14th, Vice Admiral Ōnishi convened a meeting of all senior personnel involved in the examination. The purpose was to summarize findings and assess implications for Japanese naval aviation. The meeting took place in Yokosuka's main administration building, in a conference room overlooking the base's primary runway. Ōnishi opened the meeting with characteristic directness. "Gentlemen, we have spent 8 days examining one American fighter. I require your frank assessment. Can Japanese industry produce an equivalent aircraft? Can Japanese pilots defeat this weapons system in combat? Can we develop effective countermeasures?" The silence that followed spoke volumes. Finally, Captain Jiro Horikoshi, designer of the Mitsubishi Zero, stood to respond. Horikoshi had not been directly involved in the Hellcat examination, but had reviewed all documentation. "Admiral, I will speak plainly because the situation demands honesty. The F6F Hellcat represents American industrial capability at a level we cannot match. It is not that we lack the technical knowledge to design such an aircraft. We understand every system. We could, given time and resources, create similar designs. The problem is production. The Hellcat is built for mass manufacturing. Every component is designed for automated production using specialized machinery. The tolerances are looser than we would accept, yet the overall aircraft is more robust than our finest fighters. This apparent paradox reveals sophisticated understanding of production engineering. American factories can produce Hellcats at rates we cannot approach. Their industrial capacity allows them to build adequate aircraft in overwhelming numbers rather than excellent aircraft in limited quantities. In war, quantity combined with adequacy defeats excellence combined with scarcity. Commander Fuchida added his perspective. "I have reviewed combat reports from pilots who have fought against Hellcats. The consensus is clear. The F6F is faster than Zero. It climbs better above 14,000 feet. It dives significantly faster. It rolls faster at high speeds. It has superior firepower. Most critically, it can dictate combat terms. When Hellcat pilots engage, they attack from advantage. When they face disadvantage, they simply accelerate away. Our pilots cannot force engagement on terms favorable to us. The Americans fight when conditions suit them and disengage when they do not. This tactical flexibility comes directly from superior performance." Lieutenant Inoue, who would attempt to fly the captured Hellcat if repairs could be completed, provided the pilot's perspective. "I have examined the cockpit extensively. The visibility is excellent. The controls are logically arranged. The aircraft appears forgiving to fly based on its control, harmony, and stability characteristics. Most significantly for carrier operations, the landing gear is robust and widely spaced. This suggests the aircraft tolerates rough carrier landings that would damage Japanese fighters. In prolonged carrier operations, this durability advantage accumulates. American squadrons maintain higher operational readiness because fewer aircraft are lost to landing accidents." The discussion continued for 3 hours. Every aspect of the Hellcat was analyzed: performance characteristics, construction methods, systems engineering, operational employment. The conclusion emerged with mathematical certainty. Japan faced an opponent with fighter aircraft superior in nearly every measurable category except low-speed maneuverability. This advantage was produced in quantities Japanese industry could not approach. Flown by pilots whose training was increasingly superior as Japanese training programs collapsed under fuel shortages, supported by logistics systems that ensured high operational readiness, the stark reality confronting Japanese naval aviation in January 1945 was not merely that American fighters were superior. It was that the gap was widening rather than narrowing. Every month brought reports of new American aircraft types, improved Hellcat variants, F-4U Corsairs in growing numbers, eventually P-51 Mustangs operating from Iwo Jima. Meanwhile, Japanese fighter development had effectively stalled. Vice Admiral Ōnishi understood these trends better than most senior officers. His position as commander of the 1st Air Fleet and architect of the Kamikaze strategy gave him access to the most complete intelligence available. The captured Hellcat examination had simply confirmed what scattered evidence had been indicating for months. Japan was losing the technological race decisively. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The decision was made to attempt repair of the captured Hellcat for flight testing. This would provide data beyond what static examination could reveal. Performance characteristics, handling qualities, combat capabilities. Japanese test pilots flying the present Storosov, enemy's primary fighter, would gain insights impossible to obtain any other way. The repair work faced immediate challenges. The Pratt & Whitney R2800 engine was destroyed beyond salvage. No replacement was available in Japan. American bombing had ensured that no complete spare engines existed anywhere in Japanese-controlled territory. The solution required improvisation. Engineers decided to install a captured engine from a different source. Records indicate they located an R2800 engine salvaged from a downed F-4U Corsair. The engine had suffered some damage but was deemed repairable. Over 3 weeks in late January and early February 1945, a team of mechanics worked to install the Corsair's engine into the Hellcat's airframe. The task proved more difficult than anticipated. While both aircraft used the same basic engine, the installations differed in critical details. Engine mounts required modification. Cowling panels needed adjustment. Oil cooler placement was different. Exhaust stack configuration varied. Propeller gearing was distinct. Every difference required careful engineering to resolve. By mid-February, the hybrid Hellcat was mechanically complete. Ground runs tested the engine installation. The R2800 ran roughly at first, requiring carburetor adjustments and ignition timing corrections. After several days of troubleshooting, the engine ran smoothly enough for taxi tests. Lieutenant Kiyoshi Inoue conducted the taxi tests on February 19th. Rolling the Hellcat down Yokosuka's main runway at increasing speeds, Inoue evaluated ground handling characteristics. The wide-track landing gear provided excellent stability. The tailwheel steering was responsive. Visibility over the nose was adequate despite the large radial engine. At high-speed taxi, approaching takeoff velocity, Inoue noted the controls becoming alive. The ailerons felt responsive. The elevator seemed well balanced. The rudder required significant force due to propeller torque, but was manageable. The aircraft felt solid and well coordinated. On February 22nd, Inoue attempted the first flight. The weather was clear, winds light. American B-29 raids had been heavy the previous night, but morning brought calm conditions. Yokosuka's operations officer cleared Inoue for takeoff, with strict instructions to remain within gliding distance of the base in case mechanical problems developed. Inoue advanced the throttle smoothly. The R2800 responded with a deep roar, propeller biting into the cold air. The Hellcat accelerated rapidly, far more quickly than the Zero fighters Inoue typically flew. The tail came up early. At approximately 75 knots indicated, Inoue eased back on the stick and the Hellcat lifted off cleanly. The sensation of power was immediate and overwhelming. The 2,000 horsepower engine pulled the Hellcat upward at a rate Inoue had never experienced in Japanese fighters. Climb rate exceeded 2,000 feet per minute at sea level, more than double what a Zero could achieve. Within 3 minutes, Inoue had climbed to 10,000 feet. He began gentle maneuvering to assess handling characteristics. The controls were heavier than a Zero's, requiring more force to initiate rolls and pulls. But the response was crisp and predictable. The aircraft felt stable, well-damped, resistant to pilot-induced oscillations. Inoue attempted a stall. He reduced power and gradually pulled the nose up, bleeding off airspeed. The Hellcat's stall characteristics were benign. The aircraft buffeted gently before the nose dropped straight ahead without any tendency to snap or spin. Recovery required simply releasing back pressure and adding power. He tested roll rate at various speeds. At low speed, the Hellcat rolled relatively slowly, as expected for its weight and wing loading. But as airspeed increased above 200 knots, roll rate improved dramatically. Above 250 knots, the Hellcat could reverse direction faster than any Japanese fighter Inoue had flown. The implications were clear. At high speeds, where combat typically occurred when American pilots initiated engagement, the Hellcat possessed superior roll authority. Japanese pilots attempting to evade through rolling maneuvers would find themselves at severe disadvantage. Inoue tested dive performance carefully. He rolled inverted and pulled through into a vertical dive, monitoring airspeed buildup. The Hellcat accelerated smoothly past 300 knots, then 350, approaching 400. The controls remained effective throughout. There was no tendency toward compressibility effects or control flutter. Japanese fighters typically encountered severe control problems in high-speed dives. Ailerons would freeze. Elevators would become ineffective. Some aircraft would enter uncontrollable dives, from which recovery was impossible. The Hellcat showed none of these problems. American pilots could dive away from any engagement, knowing their aircraft would remain controllable. After 35 minutes of flight testing, Inoue returned to Yokosuka for landing. The approach revealed another Hellcat advantage. With flaps and landing gear extended, the aircraft remained stable and controllable at low speeds. Visibility forward was excellent. The wide landing gear track provided confidence during the final approach. Inoue touched down smoothly, the robust gear absorbing the landing loads easily. He rolled out and taxied back to the hangar area where Vice Admiral Ōnishi and a crowd of engineers waited. Inoue shut down the engine and climbed from the cockpit. His first words to Ōnishi were recorded by several observers. "Admiral, this aircraft is a revelation. It is faster, more powerful, and more rugged than anything we have. At high speeds where Americans choose to fight, it is superior in every way except turning radius. And even in turns, the Hellcat is competitive above 14,000 feet where combat typically occurs." Over the following 2 weeks, Inoue conducted 7 additional test flights, accumulating approximately 12 hours in the captured Hellcat. Each flight explored different aspects of performance and handling. The accumulated data painted a comprehensive picture of American fighter capabilities. The Hellcat's maximum speed at optimal altitude approached 380 miles per hour. The Zero's maximum speed was approximately 331 miles per hour. The 49-mile-per-hour advantage meant Hellcat pilots could catch fleeing Japanese fighters or escape when facing unfavorable odds. Climb performance at altitude favored the Hellcat above 14,000 feet. Below that altitude, the Zero climbed slightly faster, but most carrier combat occurred at 15 to 20,000 feet, where the Hellcat's supercharged engine provided superior power. Dive performance overwhelmingly favored the Hellcat. The American fighter could dive away from any Japanese fighter without risk. This gave Hellcat pilots the crucial ability to disengage at will, choosing when to fight and when to escape. Range with external tanks exceeded Japanese expectations. With full internal fuel and 2 150-gallon drop tanks, Inoue calculated the Hellcat could conduct combat patrols over 350 miles from its carrier. This radius exceeded anything Japanese fighters could achieve while maintaining combat capability. The only clear advantage the Zero retained was low-speed turning radius. In sustained turning fights below 250 knots, the Zero could outturn the Hellcat consistently. But American pilots had learned to avoid such engagements entirely. They would not turn with Japanese fighters. They would make high-speed slashing attacks, using superior speed and dive performance to dictate combat terms. Lieutenant Commander Minoru Genda, who observed several of Inoue's test flights, prepared a detailed tactical analysis. His conclusions were sobering. The F6F Hellcat has been designed specifically to counter the Zero's advantages while exploiting its weaknesses. American pilots are trained to avoid turning engagements where the Zero excels. Instead, they use superior speed, climb rate at altitude, and dive performance to maintain tactical initiative. Japanese pilots attempting to engage Hellcats in combat face an impossible situation. We can neither force engagement on favorable terms nor escape when facing unfavorable odds. The Americans choose when and how to fight. We react to their decisions. Most critically, the Hellcat's performance advantages are not marginal. The speed differential of 49 miles per hour represents the difference between life and death in aerial combat. The superior roll rate at high speed gives American pilots escape options we do not possess. The ability to dive away without risk of structural failure or control loss means they can always disengage. Combined with superior American pilot training, numerical advantage, and radar direction from their carriers, the Hellcat represents an operational system we cannot effectively counter with current Japanese fighters or tactics. The captured Hellcat flew for the last time on March 7, 1945. Lieutenant Inoue conducted a final evaluation flight, testing maximum performance characteristics. During a high-speed dive, the repaired engine developed problems. Smoke began streaming from the cowling. Oil pressure fluctuated erratically. Inoue immediately reduced power and turned toward Yokosuka. He barely made it back. The engine was coughing badly by the time he entered the landing pattern. Inoue executed an emergency landing, touching down long and fast to avoid losing power on final approach. The Hellcat rolled to a stop, engine trailing smoke. Post-flight inspection revealed multiple engine problems. The R-2800 salvaged from the crashed Corsair had suffered more internal damage than initially apparent. Continued operation had caused bearing failures and cylinder damage. Repair would require complete engine disassembly and rebuild, assuming parts could be found. No parts existed in Japan. American bombing had destroyed or scattered any stockpiles of captured American aircraft components. The decision was made to end flight testing. The captured Hellcat was pushed into a grass dispersal area where it would remain until war's end. But the damage had been done. Not to the Hellcat, but to Japanese confidence in their ability to contest American air superiority. Every senior officer who observed the test flights understood what they meant. Japan was fighting an opponent with technological capabilities they could not match. The examination of the captured Hellcat coincided with increasingly desperate strategic circumstances facing Japan in early 1945. American forces had landed on Iwo Jima on February 19th. The fighting was brutal, but the outcome was never in doubt. Once secured, Iwo Jima would provide fighter bases only 660 miles from Tokyo. American carrier task forces were operating with impunity off the Japanese coast. On February 16th and 17th, Task Force 58 conducted massive strikes against the Tokyo area. Over 1,200 American aircraft attacked Japanese airfields, destroying an estimated 332 aircraft on the ground and 177 in air combat. Japanese forces shot down 88 American aircraft in return. The exchange ratio had become catastrophic. American losses were quickly replaced. Japanese losses were irreplaceable. Pilot casualties particularly devastated the remaining Japanese air forces. By March 1945, average pilot experience in Japanese Navy units had fallen to approximately 100 hours total flight time. Many pilots had fewer than 20 hours in their combat aircraft type. American Navy pilots entering combat in early 1945 typically had between 300 and 500 hours total flight time, with over 100 hours in type. They had practiced gunnery extensively on ranges. They had trained in tactics with experienced instructors. They understood radio discipline and formation flying. The training gap was as significant as the equipment gap. Even if Japanese pilots had been flying aircraft equal to the Hellcat, which they were not, the pilot quality advantage would have ensured American victory. Combined with superior aircraft, the advantage became overwhelming. Commander Mitsuo Fuchida, who had led the Pearl Harbor attack and was now serving in staff positions, wrote a remarkably frank assessment in March 1945. The document, discovered by American occupation forces after the surrender, revealed Japanese leadership's understanding of their situation. Our examination of the captured F6F fighter confirms what combat experience has been indicating. American carrier aviation has achieved superiority in aircraft performance, pilot training, tactical employment, and logistics support. We cannot match them in any of these areas. Japanese industry cannot produce fighters with performance equal to the Hellcat. Our best aircraft, the Mitsubishi Zero, was designed in 1937 and entered service in 1940. It remains fundamentally a pre-war design. Attempts to upgrade its performance through engine improvements and structural modifications have reached the limits of what the basic airframe can accommodate. Our newer fighter designs, including the Mitsubishi J-2M Raiden and the Kawanishi N-1KJ Shiden, show improved performance. But these aircraft are produced in limited numbers due to industrial disruption from American bombing. More critically, they still do not match overall Hellcat capabilities. The problem extends beyond aircraft design. American naval aviation operates as an integrated system. Carrier task forces include dedicated radar picket destroyers that provide early warning and fighter direction. Combat air patrol fighters are guided to intercept enemy formations by radar controllers aboard the carriers. American tactics emphasize coordinated attacks with mutually supporting elements. Fighters protect each other. No pilot fights alone. Training emphasizes teamwork over individual prowess. Japanese naval aviation has not developed equivalent systems. Our radar capabilities are limited. We lack effective fighter direction systems. Our tactics, developed when we possessed superior aircraft and pilots, have not adapted to changed circumstances. Most fundamentally, our training system has collapsed. Fuel shortages mean new pilots receive minimal flight instruction. Experienced instructors are dead or assigned to combat units where they die before they can train replacements. This vicious cycle ensures that pilot quality continues declining. The captured Hellcat represents not just superior American engineering, but superior American industrial organization, training systems, tactical doctrine, and operational logistics. We are not simply facing a better fighter. We are facing a better aviation system supported by vastly superior resources. The implications of Fuchida's analysis were devastating. Japan had entered the war with qualitative superiority in carrier aviation. Superbly trained pilots flying excellent aircraft, sophisticated tactics developed through years of combat experience in China, determination and fighting spirit. By early 1945, every qualitative advantage had been lost. American pilots were now better trained. American aircraft were superior in nearly every category. American tactics were more sophisticated. American fighting spirit, motivated by Pearl Harbor and subsequent Japanese atrocities, was as determined as Japanese resolve. The only factor favoring Japan was defensive advantage. Fighting, close to home bases, shorter supply lines, familiar terrain. But these advantages were insufficient when facing such overwhelming American material and technical superiority. Vice Admiral Ōnishi's Kamikaze strategy represented acknowledgement of this reality. If Japanese pilots could not defeat American fighters in aerial combat, they could only inflict damage through suicide attacks that guaranteed hits. The strategy was born from desperation, not from any reasonable expectation of strategic success. Ōnishi himself understood the Kamikaze program was tactical expedient rather than strategic solution. In private conversations recorded by his staff officers, he expressed profound pessimism about Japan's chances. The captured Hellcat examination had simply reinforced his assessment. The mathematics of attrition warfare were inescapable. America was producing approximately 1,000 fighters per month by early 1945. Japan was producing perhaps 300 fighters of all types monthly, with production declining under American bombing. The numerical disparity was widening. American pilots shot down in combat were often rescued by submarine lifeguard services or destroyer pickets. Japanese pilots shot down over water typically drowned. The cumulative effect meant American pilot strength increased, while Japanese pilot strength declined. American aircraft damaged in combat were repaired by skilled maintenance crews with abundant spare parts and proper tools. Japanese aircraft damaged in combat often could not be repaired due to parts shortages and maintenance crew attrition. Operational readiness rates for American squadrons exceeded 80%. Japanese readiness rates had fallen below 50%. Every trend line pointed toward increasing American dominance. Japan's situation in early 1945 resembled Germany's situation in Europe. Superior Allied production, superior Allied technology, superior Allied training, and superior Allied numbers combined to make defeat inevitable, absent some dramatic reversal. No such reversal appeared possible. Japanese war production was collapsing under American bombing. The submarine blockade had strangled raw material imports. Oil shortages crippled training and operations. Food shortages threatened civilian morale. Industrial workers were weakened by malnutrition. The examination of the captured Hellcat thus occurred against a backdrop of comprehensive strategic failure. The fighter itself was merely one symptom of broader American superiority across every dimension of warfare. But it was a powerful symbol. The Hellcat represented what American industrial civilization could achieve when fully mobilized. Every precision-stamped wing rib spoke of sophisticated manufacturing. Every interchangeable component demonstrated industrial organization Japanese factories could not match. Every system showed engineering excellence oriented toward mass production. Japanese engineers examining the Hellcat understood they were witnessing their own defeat made tangible. The aircraft embodied capabilities Japan could not replicate, not because Japanese engineers lacked knowledge or skill, but because Japanese industry lacked the machine tools, the raw materials, the electrical power, the trained workforce, and the organizational systems required for American-style mass production. The tragic irony was that Japanese industry had once pursued similar paths toward modernization and mass production. In the 1920s and early 1930s, Japanese industry had been rapidly adopting Western manufacturing methods. Japanese engineers had studied American production techniques. Japanese factories had imported American machinery. But Japan's resource constraints and the military's prioritization of immediate expansion over long-term industrial development had prevented full modernization. When war came in 1941, Japanese industry remained a hybrid. Some modern facilities using advanced techniques, many traditional factories relying on skilled craftsmen, nothing approaching the integrated industrial system America had built. The captured Hellcat examination lasted 3 months total, from early January through early April 1945. By April, American forces controlled Okinawa. American carrier task forces operated off Japan with virtual impunity. American B-29 bombers flew over Japan daily, destroying industrial facilities and urban areas. The strategic situation had deteriorated beyond any possibility of military reversal. Japan's leadership began considering surrender terms, though publicly maintaining determination to fight to the end. The examination of one captured fighter changed nothing strategically. The war was already lost, but it changed Japanese understanding of why they had lost. Not through lack of courage or determination, not through tactical failures or strategic blunders, though both had occurred, but fundamentally through industrial and technological inferiority that no amount of fighting spirit could overcome. When American forces occupied Yokosuka Naval Air Base in September 1945, they discovered the damaged Hellcat still sitting where it had been pushed months earlier. The aircraft was photographed extensively, showing Japanese markings crudely painted over American insignia. Tail code YO-801 identified it as belonging to Yokosuka Air Group. American intelligence officers interviewed Japanese personnel who had examined the fighter. Their reports documented what Japanese engineers had learned. The information proved useful for understanding Japanese perceptions of American capabilities, though by that point purely historical interest. The captured Hellcat was eventually destroyed along with other Japanese aircraft surrendered at Yokosuka. Its brief service with Japanese forces ended as it had begun, as a symbol of overwhelming American technological superiority. Part 3. The Cost of Truth. The summer of 1945 brought Japan's final reckoning with realities the captured Hellcat examination had revealed months earlier. American air superiority over Japan was absolute. B-29 bombers operated in formations of hundreds, facing minimal opposition. Carrier aircraft struck targets throughout the home islands without effective challenge. Japanese air defenses had effectively ceased to exist. The statistics told a story of complete collapse. In June 1945, Japanese air forces flew approximately 500 sorties against American targets. American forces flew over 20,000 sorties against Japanese targets. The numerical disparity was 50-1. The effectiveness disparity was even greater. Japanese pilots flying obsolete aircraft with minimal training achieved almost nothing. Many died on their first combat mission. Those who survived lacked the fuel, aircraft, or tactical training to improve through experience. American pilots, flying superior aircraft with comprehensive training and abundant support, dominated every engagement. Lieutenant Kiyoshi Inoue, who had flown the captured Hellcat at Yokosuka, did not survive to see Japan's surrender. He was killed on April 7, 1945, during Operation Tengo. The mission sent the battleship Yamato on a one-way voyage toward Okinawa, escorted by limited air cover. American carrier aircraft attacked the force mercilessly. Inoue, flying a Mitsubishi Zero, attempted to defend the fleet against waves of Hellcats and Corsairs. His aircraft was shot down by F6F fighters from USS Bennington. He died knowing exactly how superior the American fighters were, having flown one himself just weeks earlier. The knowledge provided no tactical advantage when facing multiple enemies with better aircraft, better training, and better tactics. Vice Admiral Takijirō Ōnishi survived longer. As architect of the Kamikaze strategy, he bore responsibility for sending thousands of young pilots to certain death in desperate attempts to stem the American advance. The strategy achieved some tactical successes, damaging American ships and killing American sailors. But it could not change strategic realities. When Japan surrendered on August 15, 1945, Onishi was devastated. He had believed Japanese spirit could overcome material disadvantage. The captured Hellcat had shown him the mathematical impossibility of that belief. Yet he had continued advocating kamikaze attacks, seeing no alternative. On August 16, the day after the surrender announcement, Onishi committed seppuku in his quarters. He left a note apologizing to the families of the approximately 4,000 kamikaze pilots who had died under his command. His death was both traditional warrior's response to defeat and acknowledgement that his strategies had failed. Captain Minoru Genda survived the war and later served in Japan's post-war air self-defense force, eventually reaching the rank of general. In post-war interviews, he spoke candidly about the captured Hellcat examination. When we examined that F6F at Yokosuka, we understood immediately that we were seeing the future of naval aviation. Everything about it spoke of American industrial superiority, not just the aircraft itself, but the entire system it represented. American carriers launched aircraft like that by the dozens. They had spare parts in abundance. They had trained pilots arriving continuously. They had fuel without limit. They had ammunition in such quantities they could afford extensive gunnery training. We had courage and determination. They had courage, determination, and overwhelming material advantage. In modern industrial warfare, material advantage ultimately determines outcomes. The Hellcat proved that conclusively. What pained us most was knowing that Japanese engineers understood how to build aircraft like the FAF, Hellcat. We had the knowledge. What we lacked was the industrial capacity to produce such aircraft in the quantities needed. We could not match American factories, American electrical power generation, American raw material access, American machine tool production. The war was lost in factories and on assembly lines as much as it was lost in battles. The captured Hellcat was merely evidence of a reality we should have recognized before the war began. You cannot fight industrial warfare against an opponent with 10 times your productive capacity and expect to win through superior spirit alone. Commander Mitsuo Fuchida also survived, later converting to Christianity and becoming a missionary. His post-war writings included extensive reflections on Japanese military failures. He returned repeatedly to the theme of industrial and technological inferiority. At Pearl Harbor, we achieved tactical surprise that gave us temporary advantage. For 6 months after Pearl Harbor, Japanese forces advanced across the Pacific and Southeast Asia. We believed we were winning through superior warriors and superior spirit. But even during those early victories, American industry was mobilizing. Factories were converting to war production. Training programs were expanding. Shipyards were laying down dozens of carriers. Aircraft plants were preparing for mass production. By mid-1942, American production was exceeding Japanese output. By 1943, the disparity was overwhelming. By 1944, American material superiority was so complete that Japanese forces could win tactical victories without changing strategic realities. The Hellcat epitomized American production capability. Over 12,000 were built between 1942 and 1945. These were not crude emergency aircraft. They were sophisticated fighters, each built to exacting standards with interchangeable parts and reliable systems. Japanese industry built approximately 10,500 Zeros during the entire war. Our best fighter, produced over 6 years, totaled fewer aircraft than America produced of just one fighter type in 3 years, and America was simultaneously producing Corsairs, Thunderbolts, Mustangs, Lightnings, and numerous other types. We were fighting a war we could not win. The captured Hellcat showed us why. The post-war examination of Japanese military technology by American technical intelligence teams revealed the extent of Japanese efforts to understand and counter American capabilities. At Yokosuka, American investigators found extensive documentation of the captured Hellcat examination. Engineering drawings showed Japanese attempts to understand construction methods. Test reports documented flight characteristics. Tactical analyses assessed combat implications. Material studies examined alloys and manufacturing processes. The documentation demonstrated that Japanese engineers thoroughly understood American technical achievements. They recognized the sophisticated manufacturing required. They grasped the production philosophy, emphasizing interchangeable parts and semi-skilled assembly. They comprehended the tactical advantages superior performance provided. Understanding had not translated into capability. Japanese industry could not replicate American production methods without American machine tools, American electrical power capacity, American raw material abundance, and American industrial organization. Knowledge without capability meant understanding defeat without ability to prevent it. The captured Hellcat had taught Japanese engineers that modern industrial warfare was won by industrial systems rather than individual weapons. Superior fighters mattered, but more important was the industrial capacity to produce those fighters in overwhelming quantities with reliable quality and consistent availability. American production philosophy proved decisively superior. Design for mass production. Build adequate aircraft in overwhelming numbers. Accept looser tolerances in exchange for faster production. Prioritize reliability and maintainability over maximum performance. Create systems simple enough for semi-skilled workers to assemble and maintain. Japanese production philosophy had emphasized craftsmanship. Build the best possible aircraft. Accept slower production in exchange for higher quality. Require skilled workers for assembly and maintenance. Optimize for maximum performance, even at the cost of complexity and difficulty. In peacetime, Japanese philosophy produced excellent results. In total war against an opponent with vast industrial superiority, it guaranteed defeat. The lessons from the captured Hellcat examination influenced post-war Japanese industry profoundly. Engineers who had studied American aircraft during the war applied those lessons to civilian manufacturing. They understood that mass production required different approaches than craft production. Companies like Toyota studied American manufacturing methods extensively. They adapted American production techniques while adding Japanese emphasis on quality control and continuous improvement. The result was industrial capability that eventually matched and exceeded American productivity in many sectors. The irony was not lost on those who remembered the war. Japan had been defeated partially because its industry could not match American mass production. Within 30 years, Japanese industry was teaching American companies about efficient manufacturing. The circle closed, though at tremendous cost in lives and suffering. The Grumman F6F Hellcat destroyed 5,223 enemy aircraft during World War II, more than any other Allied naval fighter. It achieved a kill ratio of 19-1, the best of any American fighter. 305 Hellcat pilots became aces. The aircraft accounted for 75% of all U.S. Navy aerial victories in the Pacific. These statistics represented more than impressive combat records. They represented American industrial capacity translated into military power. Each Hellcat carried with it the weight of American factories, American resources, American training systems, and American determination. When Japanese engineers examined Bureau number 71441 at Yokosuka in early 1945, they were examining not just a fighter aircraft but the instrument of their defeat. Every precisely stamped component, every interchangeable part, every robust system spoke of industrial capabilities Japan could not match. The examination revealed truths Japanese leadership should have recognized before Pearl Harbor. Industrial warfare between modern nations is decided by industrial capacity as much as by military prowess. Tactical excellence cannot overcome strategic material disadvantage indefinitely. Fighting spirit, though necessary, is insufficient when facing enemies with superior weapons produced in overwhelming quantities. The captured Hellcat taught these lessons with brutal clarity. Japanese engineers understood them completely. Japanese military leadership understood them too late. By the time the Hellcat arrived at Yokosuka in January 1945, the war was already lost. The examination simply documented why. The fighter itself was destroyed after the surrender, along with thousands of other Japanese aircraft that represented the shattered remnants of Japanese air power. But the lessons it taught survived in the memories of those who examined it and in the documents they produced. Those lessons shaped post-war understanding of industrial warfare. They influenced Japanese industrial reconstruction. They informed military aviation development worldwide. They demonstrated that in modern conflict between industrial powers, production capacity ultimately determines outcomes, regardless of other factors. The Grumman F6F Hellcat was an excellent fighter aircraft, well-designed, rugged, effective. But its true significance lay not in its specific characteristics, but in what it represented. American industry at full mobilization, producing sophisticated weapons in quantities that overwhelmed enemies through sheer material abundance. Japanese admirals who examined the captured Hellcat at Yokosuka understood this completely. They saw their defeat explained in stamped aluminum panels, forged steel components, and mass-produced assemblies. They recognized that Japan had challenged the world's greatest industrial power and learned a harsh lesson about the realities of modern warfare. The cost of that lesson was measured in millions of lives, destroyed cities, and Japan's complete defeat. The captured Hellcat was merely the teacher that explained why the cost had been inevitable from the moment Japan chose war with America. In the decades since, the F6F Hellcat has been remembered as one of the great fighter aircraft of World War II. Museum examples are carefully preserved. Restored aircraft fly at air shows. Historians study its combat record and technical characteristics, but perhaps its most important legacy is the lesson it taught at Yokosuka Naval Air Base in early 1945. The lesson that industrial capacity matters, that production systems determine outcomes, that in modern warfare between industrial nations, factories win wars as surely as soldiers do. Japanese engineers learned that lesson by examining one captured fighter. They documented it carefully. They understood its implications completely. and they recognized too late that knowledge without capability merely meant understanding defeat without power to prevent it. The Grumman F6F Hellcat, designed as a fighter, built as a weapon, remembered as the aircraft that dominated the Pacific skies, but understood by those who examined it at Yokosuka as something more fundamental, the instrument that explained Japan's defeat through mathematics, physics, and industrial engineering. The admirals who flew it understood immediately why their aces were vanishing. Superior American fighters flown by well-trained pilots, produced in overwhelming numbers, supported by unlimited logistics. The mathematical reality of industrial warfare, demonstrated in aluminum and steel, a lesson written in the very construction of one captured aircraft, a truth that could not be denied, countered, or overcome. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.